Okay, let's look at problem number 3. Now, it says A, to rewrite in descending order. This means we want to have the highest power first, the highest exponent. So we look here, we see that we have an exponent of 3. We put this term first. Our next highest exponent is a 2. So we put this term next. Now our next highest exponent is a 1, and we don't typically put a 1, but we can see that it's just an x. And then our last term is our constant, which is minus 1. So this is descending order. It means that the exponents are getting smaller. Next, it says identify the degree. When we have one variable, we just want to look for the highest exponent. So this will be degree 3. Part C asks us to find the leading term. The leading term means that very first term with the highest exponent. So it's going to be square root of 7 x cubed. That's the leading term. It's the first term. And D asks for the leading coefficient. So in the first or the leading term, the coefficient is square root of 7. Now the problem also asks us to make sure that it's a function. And we know that functions will only have exponents that are non-negative integers. In other words, they're positive whole numbers. So we can see we have a 3, a 2, and a 1 as our exponents, which are all positive and they're all whole numbers. So yes, this is a function. The next exercise asks us to find the zeros for the function. Now, when it's already factored, this is very easy. We just set each factor equal to 0. So my first factor, my second factor, and my third factor. Notice I didn't worry about the exponent. I'm just looking at what's inside of them. So this will become x is equal to 0, x is equal to negative 2, and x is equal to 3. So I have 3 zeros. Now we also have to state the multiplicity of each. The multiplicity is found by looking at the exponent. So let's just start here on the right. X minus 3 has an exponent of 2. So this is going to have a multiplicity of 2. Okay? X plus 2 has a multiplicity of an exponent of 3, and the multiplicity will be 3. In our first factor, x is equal to 0. Well, it has an exponent of 1, so we know this is going to just be a multiplicity of 1. Part B asks us to find the degree without multiplying through. This is not hard. We just want to look at our function and just look at the different exponents. So we know 3x, that has an exponent of 1. And we know x plus 2 has an exponent of 3. And then x minus 3 has an exponent of 2. So we're just going to add those up. So that's going to be 1 plus 3 plus 2. Okay, so our degree will be 6. So I'm just adding up the exponents of each factor. So our next problem asks us to determine if the given binomial is a factor of the corresponding polynomial. So we have a binomial, right? So we can say that the 0 for this would be negative 0.2. So if I said x plus 0.2 is equal to 0, I could solve for x and I would get negative 0.2. So our factor theorem says that if f is a polynomial function, then x minus k is a factor only if f of k is equal to 0. So what we're going to do is we're going to put in this 0 and see if it actually makes the function equal to 0. So let's try f at negative 0.2. So wherever there is an x, I'm going to replace it with negative 2. And I'm going to use my calculator to see what I get. When I entered this into the calculator, I got 0.0208. If it's not equal to 0, then that is not a factor. So no, it is not a factor. And the reason is because it was not equal to 0 when you put in the root. Our next two problems ask us to use factoring to find all the real zeros of the function. So this is why I had you do the factoring project earlier. You need to make sure you're comfortable doing factoring. If not, go back and watch some of those videos. So the first thing I always do is to find out if there's a greatest common factor. In our first problem, there's the greatest common factor of x. So I factor it out. Next, I count the number of terms in the parentheses. There's 1, 2, 3. 3 terms means I'm going to use a trinomial factoring method. Maybe you use AC method, maybe you use reverse FOIL, whatever method you like. So I know that I'm going to have two binomials, and I'm going to use 7 and 3, because 7 times 3 will be 21, and I'm going to use minus 7 and a plus 3, because minus 7 plus 3 will give me minus 4. So I'm left with 3 factors. Now notice I make sure I put my greatest common factor in the very front. The zero factor property says that if I set each factor equal to 0, I'm going to find those roots or solutions for the problem. So I'm going to get x is equal to 7, x is equal to negative 3, and x is equal to 0. Those are my real zeros. My next problem, 2x cubed plus x squared minus 8x minus 4. First, I look to see if there's a greatest common factor, and there's not. Then I count the terms. There's 1, 2, 3, 4. 4 terms means I'm going to use factor by grouping, which is just two mini problems. To use factor by grouping, I look at the first 2 terms, and I see if they have a greatest common factor, and they do, x squared. I factor it out. Next, I look at the third and fourth terms, and I say, do they have a greatest common factor? They do. They have a 4. Now, I want to make this factor and this factor match, so I'm going to factor out a negative 4. And then I'm going to reunite both halves of my problem. Now, my greatest common factor now is going to be 2x plus 1. It's in both of those terms. So I'm going to put it in the front. And whatever's left, so x squared minus 4, will go in the parentheses following it. When you're done, you need to make sure that you can't keep factoring. So we see that 2x plus 1 is, you can't factor any farther, but x squared minus 4 is a difference of squares. And we know difference of squares will be x plus 2 times x minus 2, and then we'll have 2x plus 1 in the front. To find the zeros, we set each factor equal to 0. So 2x plus 1 is equal to 0, x plus 2 is equal to 0, and x minus 2 is equal to 0, and we solve. So our first factor is x is equal to negative 1/2. Our second factor is x is equal to negative 2. And our third solution is x is equal to 2. So let me say that again. So these are going to be our 3 zeros. X is equal to negative 1/2, x is equal to negative 2, and x is equal to 2. So zeros are the same thing as saying solutions. They're also the same thing as saying your x-intercepts, if that makes more sense. And some people call them roots. Okay? Problem 27 asks us to factor completely. Now, we first look for a GCF. We do not have a greatest common factor. Next, we count the number of terms. We have 2 terms. Since we have 2 terms, we can use difference of squares, sum of cubes, or difference of cubes. We can see this is definitely a power of 3, so we're going to use sum or difference of cubes. So let's just review those. So these are our 2 rules that you can memorize or write in your card. I always just reason them out like this. I say that if 8x cubed can be written as 2x all cubed, and 27 can be written as 3 cubed, right? So I always make a short parentheses and a long parentheses. And my short parentheses, I write the A and the B. A and B. In my long parentheses, I write the A 3 times and then the B 3 times. And then I divide them, the first 2, the second 2, and the third 2. And these products give you your other terms. It's going to be the exact same way if you memorized it. It's just, to me, it's an easier way, and I visually see it, and I don't make mistakes with my exponents. Now, for the signs, an easier way to remember it is same, opposite, always positive. And that will work for sum of cubes and difference of cubes. And when I say same, I mean as the problem, it's the same. All right. Next, I want to find all the imaginary and real solutions. So I'm going to keep going. I'm going to say, is it possible now to set these equal to 0 and to solve. So my first factor, 2x plus 3 is equal to 0. This one's pretty straightforward. I get x is equal to negative 3/2. Now I want to solve this quadratic. So I said that a is equal to 4, b is equal to negative 6, and c is equal to 9. And I use these into my quadratic formula. Now, I get 6 plus or minus the square root of negative 108, all divided by 8. So I'm going to simplify the square root of 108. And the way I do it is I write down the prime factors. So the square root of 108 is 2 times 2 times 3 times 3 times 3. Since it's a square root, I'm looking for pairs. One number comes out, and the rest are thrown away in the group. So I get 6 square root of 3. So the square root of 108 is equal to 6 square root of 3. But I don't have that. I have negative 108. So I have to remember that that's the same thing as saying I, because a negative 1 under a square root is I for imaginary numbers. So I have 6 plus or minus, and then I'm going to put an I there to remind myself, 6 square root of 3, all divided by 8. Let's clean this up. Give myself a little more room. So if I simplify this, this is the same thing as saying 6 divided by 8 plus or minus 6 square root of 3 over 8 times I, which we can simplify as, let me bring it up here, 3/4 plus or minus 3 square root of 3 over 4I. So I have two roots, negative 3/2 and then 3/4 plus or minus 3 square root of 3 over 4I. And this is an imaginary solution, and that's okay. It asks us for the real and the imaginary solutions. Number 21, let's find all the zeros. So I see it's x to the 4th, so I'm going to try to write this as two binomials. I'm going to say x squared times x squared. And to make a 6, I know that's going to be a 3 and a 2. So this will give me on the inside negative 3x squared and then negative 2x squared, which will, oh, well, that won't give me a positive in the middle, will it? So that is not right. Let's try that again. So I'm going to say x squared times x squared. That gives me that x to the 4th. To make a 6, I know that's going to either be what? A 1 and a 6 or a 2 and a 3, right? I want it to be a negative 6. So it's going to be this or this. And then I want it to add up to be positive 5. So it needs to be this one. Let's try that again. So this is going to go here, and this is going to go here. That looks better. Now I want to keep factoring, and I see that my first binomial is a difference of squares. So I can factor that one easily. My second one, though, is not a difference of squares. So I'm going to leave it like that. Now I'm going to set each factor equal to 0. And I'm going to solve. Now, when I get here, I have x squared is equal to negative 6. I'm going to take the square root of both sides. When I take the square root, I have to remember that I'm always going to put a plus or minus on both sides, on the right side. Okay. And we know that a square root of a negative number is an I, so I'm going to bring that out like this. So I do have 4 solutions, 4 zeros, negative 1, 1, and then plus or minus the square root of 6, I. Now, the next problem asks us to look at a graph, and it says to state the number of turning points. So let's look at problem number 31. Turning points are where it's changing from decreasing to increasing. So I have a turning point here and a turning point here. So I have 2 turning points. Part B says state the zeros. The zeros simply are where the curve crosses the x-axis. So there's going to be one here one here, and one here. So these will be -2, 2, and 6. Part C says determine whether the graph represents an even or odd degree function. So if the ends point in different directions, one up and one down, it's going to be odd. If they point in the same direction, both going up or both going down, it's going to be even. Well, ours, the left points up and the right points down, so it's going to be odd. D, state whether the leading coefficient is plus or minus 1. Now, if it's a +1, then we're going to have the right end point up and the left end point down. If it's a -1, I'm going to do the opposite. I'm going to have the left end point up and the right end point down. So you can see ours, our left end points up and our right end points down. It's going to be a -1 leading coefficient. Part E says, write the equation of the function in factored form. Well, this is not hard. We can do this. So we know that if these are our zeros, then our factors must be x plus 2, x minus 2, and x minus 6. Those are my zeros. And I can get them from these, I can get the factors from the zeros. Okay? Now, next I want to put the coefficient on, and we said that our coefficient is going to be a -1, so I'm going to need to put a minus on here. You can put a -1 or you can just put minus. Okay, and this would be equal to f of x. So this is our equation of our function in factored form. Now, part F says, what is it in polynomial form? In other words, you have to multiply it out. Do this, so we're just going to take two factors at once and multiply them. So first I'm going to do these two. So it's going to be -x minus 2. Next, I'm going to do these two. So I'm going to do this one, and I'm going to get -x squared plus 2x minus 2x plus 4. And then I'm going to take that product and multiply times x minus 6. Now, I myself think it's a lot easier to do these long ones using a box method. So I'm going to recommend this method if you can do it. So to me, it's a lot more orderly. What's nice about the box method too is typically it helps you sort things because you're going to be sorting on the diagonal. So for example, I can see this is going to be a bunch of x squared. So I have 6x squared, a 2x squared, that's 8x squared, minus a 2x squared. Well, those go away, don't they? So I'm left with 6x squared. And then I have a minus 12x and a plus 12x. They're going to go away. Oh, so that leaves me a plus 4x. And then a minus 24. So I'm just multiplying that out, and that will be my polynomial form of this curve. Let's look at problem number 33. So A says the number of turning points. Well, we have one here, and one here. So we have 3 turning points. And then the zeros, well, that's where we're going to cross our x-axis. So I have one here, one here, one here, and one here. So I have 4 zeros. That looks like what? -4, 0, 2, and 4. I see. Determine whether it represents an even or an odd function. I told you if they both point the same direction, that's going to be an even function. Okay? And the leading coefficient, on a positive, on an even function, if they both point up, it's positive coefficient, and if they both point down, it's going to be a negative coefficient. So we know ours is going to be a negative 1. E, write the equation of a function in factored form. We'll put this down here, it's a little longer. So we know what our roots are, our zeros. So if our 0 is negative 4, then our factor must be x plus 4. Because if you set that equal to 0, you get negative 4. Similarly, for x is equal to 0, I just put another x. And then for 2, I'll say x minus 2. And then for 4, I'll say x minus 4. And we said it had to be a minus because we said our leading coefficient would be a minus. Okay? So let's go ahead and multiply that out. We're just going to do the first negative 1 times the first factor. If I multiply that times x, that's going to give me negative x squared minus 4x. And then multiply that times x minus 2, I'm going to get negative x cubed plus 2x squared minus 4x squared plus 8x. And then I still have to multiply times x minus 4. That's what I had left. So I'm going to use the box once again to show you that I think it's a lot easier, a little neater. You don't have to use it, but I just think it really keeps things kind of orderly. So I put one of one of my factors times the other, one horizontally, one vertically, and then I just go back and forth. I say x times negative x cubed is negative x to the fourth. X times 2x squared is going to be 2x cubed. X times negative 4x squared will be negative 4x cubed. X times 8x will be 8x squared. And I'm going to do the bottom row too. Now, everything inside the box I'm going to add. So I definitely have a negative x to the fourth. I have a whole bunch of cubes. So I have 4x cubed, 2x cubed, that's 6x cubed. Oh, and here's a minus 4x cubed. So those kind of go away. And I'm left with plus 2x cubed. And then my 8x squared and my minus 8x squared, well, those go away. That leaves me with 16x squared. And then a minus 32x. And this is equal to f of x. And this is our answer for f. Number 35 says, find a function that could be represented by the given graph. There's more than one answer that's possible. But let's just think about this. We can see that we have 2 degrees, and 2 turning points, which means we're going to have a third degree polynomial. Okay? Our zeros are going to be a negative 3, 3, and 7. So we know that our factors will be x plus 3, x minus 3, and x minus 7. Okay? Our left side is going up, and our right side is going down. So this means I'm going to be going having a negative 1 coefficient because of my left is going up and my right is going down. And it's going to be equal to f of x. So this is one polynomial that could be a variation on that. So let's multiply it out. Okay, let's find a polynomial that could be represented by the given graph. So what do we know? Well, we know that x-intercepts those zeros. We know that our zeros are -3, 3, and 7. Okay, we also see that we have 2 turning points. So we're going to have a degree 3 on our polynomial. And we also see that the left goes up and the right goes down. So we know that our leading coefficient needs to be negative. So let's just go ahead and put these in. So using the zeros, I can make my factors be x plus 3, because if I set that equal to 0, it would give me -3. X minus 3, because if I set that equal to 0, it would give me 3, and then x minus 7. That's how I use my clue of my zeros. Now I put a -a in the front, because I'm not sure what the coefficient is. I just know that it's negative. Now, they give me a point here. They gave me 0, -126, and they're using that to help you find that a. So what we're going to do is we're going to put in 0 for x and -126 for y. So now I'm going to multiply this. So I'm going to have -a, and that's going to be 3 times -3 times -7. So that's going to be positive 63. So I have -63a is equal to -126. So if I divide both sides by -63, I'm going to get a is equal to 2. Okay, so let's rewrite our problem. So we're going to have negative, and then a is 2, x plus 3 times x minus 3 times x minus 7 is equal to f of x. And that's our function. For these problems, we're just kind of seeing if we understand, if you're given the equation, what the graph would look like. So let's just kind of talk about these. We know from this that our x-intercepts, our zeros, are going to be at 0, 3, and -4. We also know that the degree will be 1, 2, 3. So our degree will be 3 for our polynomial. Okay? That means we're going to have 2 turning points. Our turning points are always the n minus 1. So 3 minus 1 is going to give me 2. Okay? And I also see that my leading coefficient will be positive. Okay? Now, degree 3 means I'm going to be going something like that. I'm going to be going like that. So I'm going to have 2 turning points. And I see that my leading coefficient being positive means the same thing. I'm going to have the down, up on the right and down on the left. Okay? And then my last thing I want to look at is my intercepts, so my zeros. And I'm just going to put them on here. So if I were to make a quickie sketch, my intercepts are going to be at 0, 3, and -4. Okay? So it's going to look something like this. And that's all we're looking for, is kind of a shape. So I can see that they're going the right direction and that my end behavior is correct. Let's look at 39. Same idea. Now this one's going to have a degree of 3. I know that because I have a coefficient of 2 here and an exponent of 2 here and an exponent of 1 here. So it's degree 3. And I know that my end behavior will be, since I have a negative here, I'm going to now instead have the left be up and the right be down. Okay? I know my zeros are going to be at 1 and -3. Okay? So let's put this in here. So I sketched my graph. Now, you'll notice my left end goes up and my right end goes down. Now you may wonder, why didn't I cross over at -3? But we have to look at the multiplicity. So at -3, I have a multiplicity of 2. And since it's an even multiplicity, it means I'm not going to cross the axis. Instead, I'm going to bounce back up. Okay? So when you have an even multiplicity, you do not cross. And then over here where I just said 1, I went ahead and crossed over the x-axis. The other point I could look for is this intercept. It's kind of handy to have. This is my y-intercept, so I know that's just when I put a 0 in for x. Let's just put a 0 in x and see what we get. So that's going to be 9 times 1. This is going to be 9. So at this point, it's going to be 9. Okay, let's try some long division. So let's look at problem number 49. So I have x cubed plus x squared minus 22x plus minus 40. This will be our dividend, and our divisor will be x plus 2. So I want to start with those leading terms. I'm only looking at them, and I'm asking myself, what times x will give me x squared? Well, that would be x. I'm sorry. What times x will give me x cubed? That's going to be x squared. Okay? So I'm dividing x into x cubed. Now I'm going to actually multiply x squared times x plus 2. And this will give me x cubed plus 2x squared. So my second step, multiply. I'm going to put that product now underneath my dividend. So I'm going to say x cubed plus 2x squared. Now I want to subtract my first line minus my second one. So I'm doing this, I'm subtracting this from my first line. An easy way to do this though is just to distribute that. And you just distribute it by, instead of putting a minus with parentheses, you change each of these signs. So that would have been a plus, so now it's going to be a minus. And then you can add vertically. So x cubed minus x cubed is 0, and x squared minus 2x squared will give me a negative x squared. Next, I'm going to bring down the next line. And then I start the whole process again. So I'm going to say, what times x will give me negative x squared? And I'm going to say that's negative x. And now I'm going to multiply to see what I have in reality. So x plus 2 times negative x will be negative x squared minus 2x. And I'm going to distribute the minus by changing those signs. And then I'm going to subtract and bring down. I do the whole dance routine again. Leading term only. What times x will give me negative 20x? Well, that's going to be a negative 20. Now I'm going to multiply negative 20 times x plus 2. And I'm going to get negative 20x minus 40. I'm going to change my signs, and I'm going to have a remainder of 0. So my quotient will be x squared minus x minus 20, and my remainder is 0. Let's try 51. So I'm going to set it up the same way. Now, when I'm setting these up, I always check to make sure I have all my exponents represented. So I have an exponent of 3, an exponent of 2, an exponent of 1. So if I don't have the exponent represented, I put a 0 just to hold the place. Let's try this again. So I'm going to start with my leading terms. 2x will go into 4x cubed how many times? Well, it takes a 2 times 2 to make a 4, and an x squared times x to make an x cubed. And now I multiply 2x minus 1 times 2x squared. And I get 4x cubed minus 2x squared. I'm going to distribute the minus for my subtraction. And you can see that our remainder will be 0. Your remainder will not always be 0. Okay? And I'm going to bring down my next term. Now, my leading term here is 0. Okay? So I'm going to go ahead and put a 0 here to remind myself of that. And then I'm going to bring down my next term. And I'm going to do the dance routine again. So now my leading term, we've already done this one here, is 6x. So 2x times 3 will give me 6x. Let's see, when I multiply 3 times 2x minus 1, I'll get 6x minus 3. Okay? Now, I'm going to subtract, and when I do that, I'm going to distribute, and I'm going to get a remainder of 1. So my quotient will be 2x squared plus 3, and then a remainder of 1. Another way you can write this, though, is just by putting the remainder over the divisor and adding it onto the quotient. Like this, 1 over 2x minus 1. So this is my remainder, and I put it over my divisor. Whoop, put it over there. So that's the way you can write the full quotient if you don't want to say R1. Let's look at problem number 53. When I'm writing this, I'm always aware that I'm not leaving out any exponents. So I have x cubed, and I have x squared. But if you notice, my next term is a 5. There's no x. So I'm missing the x term. So I'm just going to put a 0 here. You can put 0x if it makes you more comfortable. And then minus 5. I haven't added anything because I'm just adding a 0. And I'm going to divide by 6x squared minus 2. Okay, so we're going to do the whole dance routine again. Just looking at those leading terms. 6x squared times what will give me negative 18x cubed? Well, a negative 3 will give me a negative 18, and an x times x squared will give me an x cubed. So we're going to actually now multiply. And we're going to put this underneath. Now, my problem is, when I multiplied, I just got negative 18x cubed plus 6x. I didn't get a square. So when I put it underneath the dividend, make sure you put it in the correct location so that when you subtract, you can make sure you combine like terms. So now that I'm going to subtract, I'm going to change all my signs. So I had a negative 18x cubed plus 6x. I'm going to change this via positive 18x cubed minus 6x. Okay? And then I have to add. So this is going to be 0, negative 18x cubed plus 18x cubed. 12x squared just comes straight down because it doesn't have anything to add to it. And then 0x plus negative 6x will be negative 6x. Okay? Now looking at my leading term here, what times 6x squared will give me 12x squared? I'm going to say that's a 2. So I'm going to go ahead and multiply those together and see what I get. I'm going to get 2 times 6x squared minus 2. And I get 12x squared minus 4. Notice again, the 4 should not go under the 6x. So I'm going to go ahead and bring this down here so that it has something to add to. So I brought this one down. Okay. Now I'm going to, I had a 12x squared minus 4, so I'm going to distribute the minus like this. 12x squared minus 12x squared is 0. Negative 6x, and there's nothing to add to it or subtract, and then negative 5 plus 4 will give me a negative 1. Okay? Now, negative 6x, I can see is a lower degree than our divisor, so I cannot divide that into it. So instead, I'm going to take my remainder, and I'm going to put it over my divisor. And I'm going to add it to my quotient. Okay, and our last problem, we did one already like this, but we said that if x plus 3 is a factor, then if we put in a negative 3, the root that's associated with that factor, then we need to make it equal to 0, or it's not truly a factor. So I'm just going to go ahead and do it the same way we did it earlier. And we can use our calculators to see what this is. So f at negative 3 is equal to 0, so yes, it is a factor.